To interpret this formula, suppose that when big X is greater than its mean, open so that big X minus mu sub big X is positive, close, then big Y tends to be greater than its mean, open, so that big Y minus mu sub big Y is positive, close. And that when big X is less than its mean, so that big X minus mu sub X is less than 0, then big Y tends to be less than its mean, so that big Y minus mu sub big Y is less than 0. In both cases, the product open big X minus mu sub big X close times open big Y minus mu sub big Y close tends to be positive, so the covariance is positive. In contrast, if big X and big Y tend to move in opposite directions, so that big X is large when big Y is small, and vice versa, then the covariance is negative. Finally, big X and big Y are independent. Finally, if big X and big Y are independent, then the covariance is 0. See exercise 2.19. Correlation. Because the covariance is the product of big X and big Y deviated from their means, its units are awkwardly the units of big X multiplied by the units of big Y. This units problem can make numerical values of the covariance difficult to interpret. The correlation is an alternative measure of dependence between big X and big Y that solves the units problem of the covariance. Specifically, the correlation between big X and big Y is the covariance between big X and big Y divided by their standard deviations. Correlation of big X and big Y equals the covariance of big X and big Y over the square root of var of big X, var of big Y, equals sigma sub big X big Y over sigma sub big X sigma sub big Y. Equation 2.26. Because the units of the numerator in equation 2.26 are the same as those of the denominator, the units cancel and the correlation is unit free. The random variables big X and big Y are said to be uncorrelated if the correlation of big X and big Y equals 0. The correlation always is between -1 and 1. That is as proven in Appendix 2.1. -1 is less than or equal to the correlation of big X and big Y, which is less than or equal to 1. This is the correlation inequality, equation 2.27.